Welcome to EDU World Space.
Basically, in this question, on an inclined plane of the angle 30 degree with the horizontal, a block A and block B is placed, and they are, obviously connected by links. So basically, we have to calculate first developed on the link. So the mass of the block is given, which is 10 kg for block A, 6 kg for block B, and coefficient of friction between the surface and the block A is 0.1, for B is 0.3. So yeah, now coming back to the next part, that we have to, obviously we have to use we have to first of all calculate the acceleration, or obviously the vertical component. So vertical component, there is no force, or though no displacement, so the force should be cancelled out. So for we have calculated first for block A. So we are writing for A, in the y direction there will be no force, so the normal reaction and minus of weight cos theta, because obviously the in the normal direction the perpendicular force will be weight of A into cos theta. Cos theta is 30 degrees, so cos 30 degree is equals to 0. So we can say that normal Na will be nothing but weight, which is 10 into 9.81 into cos 30, which is root 3 upon 2. So here normal Na comes out, 8496 Newton. Now moving back to the next part in the x direction. mm, Obviously for A in the x direction, which sine theta will be in the obviously in the motion of the direction. So where sine theta and minus of in the inclined direction. So basically that's we have calling, so minus mu A into Na. Obviously it is opposite the motion, and the negative of that one, this is the force developed in the link. So this basically become F A M into A, and so we weight into sine theta, which we have calculated. So this is 10 into sine theta is 1 upon 2 minus this mu is 0.1 into normal, which is 8.496. Yeah, that's the thing. And then we have to multiply here, that's we have missed this 9.81, and negative of f, which is equals to ma, and m is 10, so 10 into a. And now we can say that this basically become 40.55 minus f, which is equals to 10a. Let's say this is equation 1. And now for block B, we are working for the block B. So for block B, in the x y direction, this is obviously the force will be 0. So nb minus wb cos theta, which is equals to 0. So we can say that the normal will be wb, which is 6.9.81 into cos theta, which is root 3 upon 2. So this basically become nb over there, which basically become 50.97, yeah, Newton. So in x direction, we have to calculate it for the block B. So we can say in the x direction, the wb sine theta into mu b nb, and over there this force will support the motion of the block B. So this is plus f, which is equals to ma, and this basically become this is 6 into 9.81 into sine theta, which is 1 upon 2 minus mu b, which is 0.3 given, and normal we have calculated 50.997 into plus f, yeah, plus f, which is equals to mass, which is 6 kg into a. So over there this basically become 14.414 plus f, which is equals to 6a, is equals to 2. When we use the equation 1 and 2 over there, a comes out, which is equals to 3.42 meter per second square, and this force generated in the link F will basically become 6.37 Newton.